from the campus of California State University, Sacramento. This is Made at Sac State. Welcome to Made at Sac State, the video magazine. I'm Gloria Moraga. We are here to share the Sac State story and to celebrate our students and the faculty and the folks who make them so successful and prepare them for the future. Today we will focus on the College of Engineering and Computer Science. It is all that the name implies. ECS is civil engineering, computer science, construction management, mechanical engineering, and electrical engineering, and so much more. Joining us now is Dean of the College of Engineering and Computer Science, Dean Emir Jose Macari, and we have Jessica Nugent, one of our students, one of our outstanding students. So first, before we get going and I ask you about the college, Dean Macari, will you introduce Jessica to us? What kind of a student is she?
Well, Jessica is an outstanding student, but she's also very similar to many of the students that we have here at Sac State. Jessica transferred into Sac State after being homeschooled, actually, in Northern California, and she came here because her dad had come to school at Sac State. She knew what our electrical engineering program could do, and I tell you, when I first met Jessica, I thought she was a freshman. Well, she was a graduating senior and graduated with a 3.96 GPA and was our distinguished student last year. I'm really proud of the things that she's doing. She's about ready to finish her master's degree, and perhaps tell us a little bit about what your plans are for the future, Jessica.
Jessica, long-term career goals, what can you tell us?
My long-term career goals, I want to work in power systems. So it could be anything from like working at PG&E or SMUD to working at a company such as California ISO that manages the power grid system.
All right, we're going to talk more with you about the future and engineering and the power systems. First, we're going to go to the dean and have him tell us a little bit about your college. So there's a lot going on there.
The college has a long tradition, Gloria. We're actually older than UC Davis. We're 51 years old, and we celebrated our 50th anniversary last year, and we're very proud. It's got a long tradition. Bottom line, I'll tell you this. Industry and government agencies prefer our graduates than any other students from any universities in all of Northern California. That should give you an idea of the type of students that we have. They're just fabulous. We're very, very proud of the work that we do, and our mission is to graduate the best possible engineers and computer scientists from all of California.
How connected are you to the Sacramento area?
Well, our students get exposed to a lot of industry and government agencies early on in their careers. They receive internships. Jessica has been an intern, summer intern with a company that was so impressed by her work that they made her an offer that she couldn't refuse. So as she's starting to work this year, she's also about to finish her master's degree. And my hope, I've told Jessica, is that she goes on to get her PhD and comes back full circle to teach at Sac State for us in the Power Systems program. So we work a lot with local industry. One of the reasons that we do that is because we have a program called Senior Design or Senior Research, in which groups of students of 4 or 5 students get together and try to address a local problem. A problem that a company in our region has, and they have not been able to solve it. And they come to our students. We treat them as their clients. You know, we are the employees, and they're hiring us to do this work. And they gain so valuable experience that many of them go on to do internships and be hired by those same companies afterwards.
Dean Macari, I would like to talk a little bit about the Smart Grid Center, the work that you're doing with earthquakes. You have some expertise in, well, you tell me, kind of go through the list of some of the departments and the work that you're doing.
Yeah, we're very lucky because 6 years ago, we applied to and formed the Center for Information Assurance and Security, which is a designated center of academic excellence by the U.S. Department of Homeland Security and the National Security Agency. We are the people that are graduating cyber guardians of the future. And we all know how important this is because we hear it in the news all the time, people being hacked, and hacking will continue. However, we need to be able to protect ourselves as much as possible. So that's one of the programs. I'm very proud of the work that we do in earthquake engineering. We have an earthquake structures lab to die for. One of the best in all of California, barring maybe 2 or 3 University of California laboratories. We are the best in all of the CSU, and we perform work there that is instructional as well as research, innovative and cutting-edge research that is helping agencies like Caltrans and building contractors to better build structures that will withstand seismic activity, which we know is very important here in California.
We're just almost out of time.
Okay.
But I wanted to give Jessica a chance. Any last comments about your education at Sac State?
It's been phenomenal. All the instructors are great. They really want you to learn, and it's wonderful here.
Let me just give a big plug into the California Smart Grid Center. This is something that we developed a few years ago and has really made a big impact to the entire region and to the entire country. So I'm very happy that it is here. It's made at Sac State.
Thank you both for joining us, and Dean McCary for setting the tone for the rest of the show. Some of the things that you mentioned and talked about, we will be hearing more about from some of the folks that are directly involved in these other departments in your college.
And I'm very happy that we brought Jessica along because she really is a model student for us.
Thank you. Thank you both. What is the California Smart Grid Center? And we'll have the answer to that coming up.
That's in addition, if it's not happening right now as part of the Smart Grid, it eventually will be part of the
I'm Brittany Peterson, and I graduated with my mechanical engineering degree in 2012, and I'm made at Sac State.
I'm Jake Ruivivar. My major is power engineering, and I'm made at Sac State.
How exciting is this? Sacramento State is home to the California Smart Grid Center. And we've got 2 professors here to tell us a little bit about what the California Smart Grid Center is. We have Professor Suresh Vadva and Professor Mohammed Vaziri. Thank you both for being here. We'll start with you, Professor Vadva. What is the California Smart Grid Center?
So Smart Grid Center is involved in research, grids research, and also in informing the public by short courses that we have and also lecture series. We are also involved with the development of certificate programs that we are working on right now.
Now, I know we hear a lot about blackouts and brownouts and turn off your electrical power. Professor Vaziri, how do we kind of waste a lot of energy in this country? And how does smart grid kind of make us all smarter and show us, help us out with this?
Well, a smart grid from each perspective is a little bit different. If we think about from the utilities perspective, for example, a smart grid is a grid that is fully automated. It can recover its outages on its own automatically by communications and other means. Also can balance the supply and the demand or the load and the generation equally in a good optimized manner. Now, from a perspective of a user, for example, or a consumer, then that is the choices of having to know when to use their energy for their optimum prices and best benefits from their perspective.
I want to get a little bit into what our students are learning and the kind of research that they're doing. And I've been over to the lab and kind of been at the Smart Grid Center, and you've got your students kind of working with sensors and home computers so that we can kind of monitor at home the electrical use that we have. Tell us how that works.
Our research in the Smart Grid Center is involved into 3 areas. One is the grid security. The second one is on sensors and automation and home area networks. And the third one is on distributed generation. And distributed generation, which also includes integration of renewables into the grid, which is photovoltaics, wind, and other means.
Okay. Tell us a little bit about those sensors, because I'm just trying to give folks to show them how far we've come with just our use of electrical energy in this country.
Okay. At this time, the grid energy need is complex, and it's also increasing. The utilities have to meet the demand of the use. In the homes before, when the grid was built or started in 1890s, we had only, at home we had maybe a couple of light bulbs. Now we have number of appliances.
Yes, for sure.
And we have televisions. We are adding electric cars.
Yes.
So the demand going up, the utilities, it's mandated that they will be moving into time of the day pricing.
Oh.
When the demand of the energy is high, the price of the energy will go up. So if the consumers are informed about the need for energy, the price of energy, they can schedule their use when the price of energy is low. For instance, they can schedule their pool pumps at night. They can also schedule washing dishes at night, maybe, drying their clothes at night rather than during the day or during the peak periods.
All right.
And with the addition of information, the consumers are empowered to control the use and the price they are willing to pay for the energy.
Professor Vava and Professor Vaziri, thank you so much for being here. There is so much to learn at the Smart Grid Center, and we will put more of this information online. And thank you for being here. And if you want to find out some more information about the College of Engineering and Computer Science and the California Smart Grid Center, you can log on to our website, csus.edu/made/TV.
Hi, I'm Alexander Cerna. My major is electrical engineering, and I'm made at Sac State.
Hi, I'm Ashley Gregory. My major is computer science, and I'm made at Sac State.
Hello, I'm Gloria Moraga. Joining us now, Professor Benham Arad and student Jason Lansborough. Thank you both for being here. Let's first talk a little bit about something President Obama said recently. He declared that the cyber threat is one of the most serious economic and national security challenges we face as a nation. I'd like to talk a little bit about the Cyber Corps Scholarship for Service grant. Professor.
This grant is actually the result of a presidential directive during the President Clinton era that basically was meant to boost the workforce in the cyber security area. It has brought about $1.2 million to our campus. It is meant to support the education of undergraduate and graduate students in computer science and computer engineering. Those students who are willing to get expertise in the information assurance and computer security area.
Okay, why is this important to our campus? Not everybody gets this grant, correct?
Exactly. So it has given our campus a lot of visibility. We are among a select group of universities who have received this prestigious grant, maybe about 50 universities nationwide. It obviously has brought funding for a group of our students who don't need to worry about funding their education, and they can basically focus on studying and gain expertise and contribute to this important area. It also has a faculty development aspect to it. We have funding to support faculty trips to technical conferences, to workshops and trainings, which is very important at this time.
All right, Jason, you are a grant recipient. Tell us about your area of study and what are your kind of your long-term goals?
So my area of study typically has been focused on malware analysis and digital forensics.
Tell me what malware analysis is.
So for malware analysis, you take something like a virus or a Trojan or some other malicious software, and you try to figure out what it's doing, you know, how it infected the system, what it might be stealing, that kind of thing.
And then go on, because we'll start like you know, you're really educating us here on cybersecurity. What else?
Okay. Also, while you're analyzing the malware, you may be able to determine who might have, you know, distributed that malware based on what they're after and the level of sophistication.
How excited are you about being involved in this program and working here at Sac State with our professors?
It's great. I was actually here as an undergrad, and I was working part-time throughout that entire process, whereas when I came back as a graduate student, I received the scholarship, and so that's been allowing me to just focus full-time on school and, you know, do other things on the side, like learn more about malware analysis.
Okay. We are going to continue our discussion on cybersecurity in the College of Engineering and Computer Science. Be right back.
No one will ever guess that your password is no more cheese dip, and it's fairly lengthy. Computer will never, probably never guess that.
Welcome to Made at Sac State, the video magazine. I'm Gloria Moraga. We are now joined by Professor Isaac Gonza and student Jason Lansborough. Thank you. Professor, I want to start with you. Please describe Sacramento State's Cyber Security Center.
Our Cyber Security Center is called CIAS, which means Center for Information Assurance and Security. Our center's mission is to collaborate with industry, with government, and also with educational institutions. Our job is to educate students on cybersecurity issues, on how to attack and how to defend systems. We also do research in this area. We do consulting in this area. We've done some consulting with some of the state agencies in the past.
And Jason, as a student and someone who's worked in the cybersecurity lab or studied there, describe your Sac State experience with the learning from professors and at Sac State.
Okay, it's been very positive overall, and learn an awful lot. Particularly the network security class, which I took as an undergrad. We did a competition where one team's attacking, the other team's defending, which was really fun. It basically, you know, gives us a kind of a more practical environment to, you know, try things out on, make sure we know what we're doing.
We are looking forward to getting some more information on that class. Professor, describe that. What's the scenario? How is it set up?
Yeah, so one of the objectives of this class is to actually teach students how to defend systems. But what we've learned over the years is that any kind of defenses that you put in, attackers are able to find some exploits to withstand those defenses. So one of the things we want to teach students is to learn how attackers behave, the methods they use, their modus operandi, and the tools they use, so that the students can, once they design a system that can be defended, they also attack those systems to make sure the defenses are working. So in that class, the students learn how to attack and defend systems that way.
And is that, Jason, from your point, you have some students in one room and students in the other room, and pretty dynamic, pretty tense?
Yeah, we're not even allowed in the other room. So you can't, you know, try to spy on what they're doing. You just gotta, you know, do it through the computer.
How quickly is the technology changing or morphing so that the minute you start to figure out a way to defend or to protect your computer, somebody develops some way to hack into it?
Yeah, so technology is changing in many ways. Not only the fact that the computer you're using, if you put in defenses, somebody's attacking, but also we have different technologies. For example, today we have smartphones that are like small computers, and these smartphones can connect to the internet, and these smartphones, so as a result, these smartphones can actually be used to attack people, and those smartphones also, people can actually attack them. What happens is that we have to learn how these smartphones work from the point of view of defending them, and also even from the point of view of doing forensics. That means in case an attack occurs on a smartphone, how do you find out what attack occurred, and how do you do forensics to determine who caused the attack, and so on and so forth. And as a matter of fact, Jason is doing a research project in that area, looking at Android phones and how to do forensics on those. So those are examples of changes in technology.
Thank you both so much for joining us. Jason, good luck with your studies. We need you out there.
Yep.
So thanks so much. I'll have you check on my my smartphone right after this segment.
All right.
All right. Thank you both so much for joining us. And stay with us because coming up, ladies and gentlemen, start your engines.
Here's our kill switch stipulated by the rules. That's off. Here's our starter. Here's our ECU. And then we have some traction control switches here.
Hi, my name is Matthew Yamasaki. I'm an electrical engineering major, and I'm made at Sac State.
Hi, I'm Gabe Thompson. I'm a computer science major, and I am made at Sac State.
So when we start to build the car, we usually start with the frame, which is the skeleton of the car, and we have to individually...
Welcome to Made at Sac State, the video magazine. We are talking about mechanical engineering and Hornet racing. Thank you so much for being here, Marcos Navarro and David Braden, and you are members of Hornet Racing. Tell us what this is, and I can hardly wait to get into this and ask you to describe all of these things. But first, Hornet Racing, what is it?
So Hornet Racing is a club here at Sac State that's part of an international competition called Formula SAE, and our chapter is called Hornet Racing.
Okay.
So what we do, our team specifically, we take about a year after competition during the summer to design and build and manufacture and test, and then later again compete a Formula style race car.
All right. And David, tell us, so we have some props here on the set. This looks like something that would be on my vacuum cleaner. Describe this. What is this exactly, and how does this relate to the rules of Formula racing?
This is the throttle plate and restrictor for our vehicle. So for our competition, because it's student built, they want to limit the amount of power we have. And they do that by forcing us to have the entire engine breathe through this little restrictor. It's about the size of a quarter.
Wow.
And despite that, we're still getting nearly stock power out of the motor.
How do you do that?
It's done with careful wave tuning of the exhaust and intake and cam overlap. So you build up a column of air and it has momentum coming through here. And when your cylinder opens, all of that air rushes in, it bounces to one side, and the valve closes before it escapes.
Marcos, the team, designs the car, and then you build these parts and weld them all together. I mean, explain how the process works.
So with this specific part, this is actually the part that connects the wheel to the suspension. So here's you have your part where it connects to the suspension right here. Oh, sorry, it's this way. Anti-roll bar, and this is the part that kind of rocks right back and forth. So this is actually from 2012, and this is what's designed going to be on the 2013 car. So
how has this improved from here to here?
You take the suspension geometry and kind of see where you want the movement to go. And through analysis, they build this on the computer and then analyze it on the computer to make sure the stresses aren't too great in certain areas, and then kind of keep iterating that design until finally you get something you want to make. And they put this in, then they take another set of computer programs to make this in a language that the machine can understand and make it for us.
Okay. And tell us a little bit about your winning record. More and more we see you competing and really building the cars that win.
Right.
And so tell us about the last couple of years.
Right. So past couple of years we've been raising places. We actually jumped 10 places from the year before. and we hope jump another 10 places out of about 80 to 100 teams that compete at Nebraska where we go. So it's not necessarily that we want to go first place, and nobody really has that goal of that's what we're going to do first place, because the competition isn't necessarily well, it is necessarily who could win, right? We're trying to win, right?
Yeah.
But it's not first place for a team that's probably kind of been developing. This is like a third-year team almost. It kind of because the knowledge kind of drops out, right?
Yeah,
When people graduate. So we're creating our own problem and finding that solution isn't necessarily going to be first place. It's going to be what's the maximum amount of points we can get out of each of the events in the competition.
This is a great piece here that you brought. That's the nose of the car.
Right.
That was from last year?
Right, from 2012.
And you have the names of your sponsors, and we thank all of those people for sponsoring Hornet Racing. And thank you. And you're both just learning a lot, aren't you, at Sac State in Mechanical Engineering?
Oh, yes, definitely. Because it's stuff that's outside of the classroom. Like I said before, you create your own. It's instead of being in the classroom, you create your own problem and create a set of solutions and try to refine it to see which one actually works for you.
All right. Okay. We'll have more on Hornet Racing. I'll tell you what it is. Stay with us.
I'm Lynn Korup. I have my bachelor's and master's at Sac State. I'm made at Sac State.
My name is Stephen Breimer. I'm a computer engineer, and I'm made at Sac State.
I'm Alex Gonzalez, president of the university, and we're proud of all of our students who are made at Sac State.
Thank you for joining us. Made at Sac State, the video magazine. Today we examined the College of Engineering and Computer Science. And we leave you now with some fabulous video from the Hornet Racing team. Please enjoy.